Hello students and welcome back. We're going to be practicing some balancing equations because the best way to get better at balancing equations is just keep practicing it. So I got a couple problems lined up for us. Some are easy, some are challenging, but we'll see if we can't get through these together. So if you want to pause the video, try the problem, and then let the video play, I highly recommend it so you can see if you know what you're doing without an explanation. So with that said, let's just jump straight into it. So looking at the first one, first thing I want to do is I want to separate my reactants and my products, make a little separation line. So I want to balance the left side, which is reactants, to the product side, which is the right side. I need all the atoms of the elements on the left side to be the same amount as the atoms of the elements on the right side. So let's see if we can get that figured out. So let's break this down just a little bit further. So on the left side, the reactant side, I got a mercury and an oxygen, and those are 1 and 1. On the right side, the product side, I also got that mercury and oxygen. Mercury's 1, oxygen's 2. Alright, let's go from there. So my mercury at the moment, my mercury's fine. It's 1 and 1. No worries there. But when we look at oxygen, it's 1 and 2. That's unbalanced. We got to fix that. So you want to ask yourself, how many times can 1 go into 2? 1 can go into 2 times. So if I multiply this by 2, I'll get 2. So what I want to do is this oxygen on the left side, I want to multiply it by 2. To do that, I use a coefficient, a large number. Because remember, I can't do subscripts. Subscripts change the compound. You got to use coefficients. But once you use this coefficient, not only does it multiply oxygen, it also multiplies this mercury. So now this mercury is also multiplied by 2. So now my mercuries are out of balance. So once again, you got to ask yourself, how many times can 1 go into 2? Well, it can go 2 times. So 1 times 2 will give me 2. So the mercury on the right now needs to be multiplied by 2. So I'll stick a 2 right there. Now double check my work. So I got 2 mercuries, 2 mercuries. So that's good. I got 2 oxygen, 2 oxygen. So that's good. Now we're balanced. Now, this compound doesn't have a number in it. Now, it doesn't necessarily need 1 because it's understood to be 1 since there's a compound there. But if you want to put a 1, you can, and that is not inaccurate. That is not wrong to do so. Some people do, some people don't. All right, let's look at the next one. Again, I'm going to put my separation line down here. I'm going to break it down. I got sulfur at 8. I got oxygen at 2. Sulfur at 1. Oxygen at 3. So now we got to worry about balancing. Doesn't really matter where you start. I think I will start with sulfur though. So if this sulfur is 8 and this one's 1, well, how many times can 1 go into 8? Well, simple. That's 8. So if I multiply it by 8, I'll get 8. So this sulfur on the product side needs an 8 in front of it. Once I do that, it balances my sulfur out fine, but then it changes my oxygen because it multiplies my oxygen by 8 as well. Well, 3 times 8 is 24. So I have 24 oxygens on the product side, 2 on the reactant side. So how many times can 2 go into 24? Well, that's 12. So if I multiply this left oxygen by 12, it should balance out. And as always, let's check our work. Sulfur is 8. Sulfur is 8. Sulfur is good. Oxygen is 12 times 2 is 24. 8 times 3 is 24. My oxygens are good. And I'll just go ahead and stick a 1 right here so it's not blank. Alright, next set. This next one looks a little bit tough, but we can handle it. So let's first separate it to our sides. So I got a left side, I got a right side. Now let's figure out all these elements because there's a lot of them. I have 2 iron. But one thing I noticed is this SO4 is together on both sides. Since they are together on both sides as sulfate, we don't have to break it apart. We could balance the sulfur and the oxygen together as one item. and it makes it a little bit easier. So that's what I'm going to do. So I'm going to put here, I have SO4, and there are 3 of them. All right. On the other side, I only got 1 SO4, but they stay together. That's the key. I got a potassium. There's 1 of them. And again, OH. OH, that polyatomic ion stays together on both sides. I don't want to break it apart. I want to balance them together. Makes it a little bit easier. So my reactant side, I have 1 hydroxide. Other side, I got 3. All right. On the product side, I have 2 potassium. I have a SO4. There's 1 of them. I have an iron. There's 1 of them. And I have a hydroxide. There's 3 of them. Now we got everything separated, we can get to work. Alright, doesn't really matter where you start, but I think I might start with one of these polyatomic ions. Now I see they have an odd number. Odd numbers are hard to deal with, they're hard to balance. So if you make those even right off the bat, sometimes that helps. And if it doesn't work, you can always go back and start again. So what I'm going to do is I'm going to start with sulfate. Since that's an uneven number, I want to multiply that by 2 right off the bat. So now I got 6 sulfates. So on the product side, I only have 1 sulfate. So 1 goes into 6 times. So if I multiply this by 6, I'll get 6. So my sulfate on the product side needs to have a 6. Now we can continue on. We changed iron earlier, so let's take a look at it. 2 times 2 is 4 iron. So I had multiplied iron by 2 with my coefficient. So now it's 4. Well, this iron on the product side is 1. Iron over here is 4. 1 goes into 4 times. So I need to multiply this iron on the product side by 4. The last thing I got to look at is my hydroxide and my potassium. So this 4 is also multiplying hydroxide by 4. So 4 and 3 make 12. Over here I just got 1. Check my potassium because we multiplied it by 6. 6 times 2 gives me 12. So I got 1 going into 12. I got 1 going into 12. So both of these need to be multiplied by 12. So I multiply that KOH by 12. Now since I doubled it at the beginning, it did make it inaccurate at the moment, only because this is not the simplest form. So when you use that strategy, always make sure you check to make sure everything's the simplest form. In this case, everything can be divided by 2. So I divide my first value by 2. I get a 1. Next value by 2. I get a 6. Next value by 2. I get a 3. And the last value by 2. I get a 2. Now you didn't have to double it at the start. That's just something I like to do because I find it makes it a little bit easier to balance. Though you do got to watch to make sure you're in simplest form. So always be wary of that if you choose to take that route. Alright, let's look at the next one. Let's set up our split and pick out our elements. So I got 10 carbon, 16 hydrogen, 2 chlorines, 1 carbon, 1 hydrogen, 1 chlorine. Let's see what we can do with this one. I'm just going to start with this carbon molecule. I'm going to try to save this chlorine for last maybe. So let's see what happens. So I got 10 and 1. Well, 1 goes into 10 times. So if I multiply this by 10, it should correct it. So my right carbon needs to be multiplied by 10. It's by itself, so nothing else is affected. Now let's look at hydrogen. 16 and 1. So if I multiply this by 16, it should correct the hydrogen. So my right hydrogen needs to be multiplied by 16. Now I got 16 and 16, but it also affects the chlorine. It multiplies it by 16. So this chlorine is 16. This one's 2. Well, 2 goes into 16 8 times. So if I multiply it by 8, it'll bring it up to 16. So my left chlorine needs a 16 in front of it. And then this one, this carbon molecule, has a 1. But let's double check our work just in case. I got 10 carbon, 10 carbon. Looks good. 16 hydrogens, 16 hydrogens. Looks good. 16 times 2 is 32. See, I done made a boo-boo. It's a good thing I went back and checked my work. Always double check your work because it's not supposed to be a 16. It's supposed to be an 8. So let's just correct that real quick. Now it's an 8. So 8 times 2 is 16. There we go. Now we're good. Remember, always double check that work. Doesn't matter how good you are at doing balance equations or how long you've been doing it. Making a mistake can be easy. It can cost you those big points on a test. Always double check your work. Next set. Let's separate our sides. I got 1 aluminum, 1 iron, 1 oxygen, 2 aluminum, 3 oxygen, 1 iron. Alright, so where do we want to start? Well, first thing I see is that uneven number. I don't like that at all. It's going to mess me up in the long run, most likely. So what I'm going to do is my double strategy. Most times it works, sometimes it doesn't. And sometimes when it does work, you got to just check the ratios just to make sure everything's simplest form. So let's see what happens. So since I want to get rid of that odd number, I double it, make it even. So if I double it, I would get 6. So I put my 2 right there. And since I put a 2 in front of this aluminum, it also multiplies it by 2. So now I got 4. So now we move on to the left side to check it. I changed my oxygen to 6. This side has 1. So if I multiply it by 6, it should bring it up to 6 as well. So my left oxygen needs a 6 in front of it. But that also multiplies my iron by 6. So now let's check the other iron. I got 6. I got 1. Well, if I multiply it by 6, it'll bring it up to 6. So my right iron needs a 6 in front of it. Last thing to do is check my aluminum. I got 4. I got 1. 1 goes into 4 times. So this aluminum needs a 4. And I look at my work and I notice immediately it's not the simplest ratio, so let's fix that right quick. So I need to divide each of these by 2. 4 divided by 2 is 2. 6 divided by 2 is 3. 2 divided by 2 is 1. 6 divided by 2 is 3. Now again, you don't have to double at the beginning if you don't want to. You could have started with the oxygen having 3 and balance the other one to 3. It's okay if you do. I just like to do the double strategy because with some of the more complicated ones, it has helped me in the past. It's just something I like to do. But you're free to do it however you understand it. Let's check our work real quick. 2 aluminum, 2 aluminum. We're good there. 3 iron, 3 iron. We're good there. 3 oxygen, 3 oxygen. Everything's balanced. Alright, next problem. Split our sides. I got 3 hydrogens. I see a PO4, a phosphate, but I don't see phosphate on the other side. So that means this time I got to break down my polyatomic ion, unfortunately. So I got 1 phosphorus, I got 4 oxygen. Other side I got 4 plus 2 hydrogens makes 6. 2 phosphorus, 7 plus 1 oxygen make 8. Now, even though these are combined in my chart, remember these are split apart. These 2 atoms, these elements, the hydrogen and oxygen, are split apart. Could cause problems later, may not. Let's just see. Alright, let's see if what we can't balance. I see that odd number right there. I don't like dealing with that odd number. So immediately, I'm going to double it. So I double that 3 to make it 6, just to make it even. That also multiplies my phosphorus. That also multiplies my oxygen. Oh, looky there. Let's look at our numbers now. 6, 6, 2, 2, 8, 8. So 2 times 3 is 6. 4 plus 2 is 6. Hydrogens are in balance. 2 phosphorus, those are balanced. 2 times 4 is 8. 7 plus 1 is 8. Oxygens are balanced. Everything's fine. Alright, next step. Let's make this split. Alright, so we got a large carbon molecule. I got an oxygen by itself, carbon dioxide and water. So when I see a combustion reaction, even though this one is reversed, I always like to do this big carbon molecule first, save this individual oxygen molecule for last. That's just my strategy. You're welcome to do whatever you're comfortable with though. So let's break it down. Got 1 carbon, 3 oxygens, 2 and 1 make 3, and 2 hydrogens. I got 6 carbon, 6 and 2 make 8 oxygen, and my hydrogen is 12. So I'm going to do this big carbon molecule first. I got 6 and 1. 1 goes into 6 times. Just multiply that by 6. So this left carbon needs a 6 in front of it. That then changes my oxygen as well. But since I'm going to do this oxygen molecule last, I'm not going to multiply that oxygen just yet. I'm going to move on to hydrogen. I got 12 hydrogens, I got 2 hydrogens. 2 goes into 12 6 times, so multiply this by 6. So my left hydrogen needs a 6 in front of it. So I'm going to have to rewrite this oxygen since it's split up like that. Make it a little bit better to read. So I got a 2 times 6 plus a 6 times 1. 2 times 6 is 12 plus 6 is 18. On my other side, I have 8. There's no way I'm getting 8 to go into 18 to get a nice clean number. And if I do 18 times 8 to get a common number, it's going to be really huge. I don't even worry about that. So this one does a little special trick. I'll show you 2 ways. I'll show you just a thought process, and I'll show you a mathematical way. So when I see this, I need to balance this oxygen and this oxygen at the same time I'm balancing these oxygens over here. But since this one's by itself completely, it's going to be very easy to manipulate. And I don't want to touch this one. If I put a coefficient in front of this molecule, it's going to change the whole scheme of things. So what I'm going to do is I'm going to ignore these 6 oxygens. Just going to completely ignore it. So if I'm ignoring 6 oxygens, I really am only dealing with 2. Now if I ignored 6 on the right side, I got to ignore 6 on the left side. 18 minus 6 is 12. So 2 can go into 12 how many times? Well, that's 6. So if I multiply this oxygen by 6, I get 12. So this right side oxygen needs a 6 in front of it. This oxygen doesn't get anything because I ignored it. And I put a 1 right there. So we go through, if we check our work, we'll find everything's even. But in case what I just did for the oxygen was confusing, let me show you another way. Let me show you a math formula way. Alright, since this is balancing equations, we're dealing with equations. So that's what I'm going to make just for oxygen. We'll make an algebra equation. So on the left side, I have 18. Well, 18 is set equal to the right side. On the right side, I have 6 plus 2x. I got the 6 from this oxygen with the 6. I got the 2 from the subscript 2, and the x is this value here that I'm looking for. So this is just a standard algebra equation. So just solve for x. So minus 6 from both sides gives me 12 equals 2x divided by 2. X equals 6. So this missing variable here is 6. Hopefully you understood that, and if you understood that, hopefully it makes the previous method I use a little bit more understandable, because it's essentially the same thing. I'm subtracting those 6 oxygens. That's where that 6 comes into play. Alright, next one. Let's split this thing up. I got a carbon, there's 1. All oxygen, there's 2. A nitrogen, there's 1. A hydrogen, there's 3. On the other side, I got 2 oxygens. I got 1 carbon. I got 2 nitrogens. I got 4 hydrogens plus another 2. That's 6. And I think I got all my atoms there. Let's see. Oxygen, carbon, nitrogen, hydrogen, all accounted for. Now let's see if we can't solve this thing. Alright, so where to start? First thing I see is this uneven number. I don't like it. I don't like that one bit. So I'm just going to double it right off the bat. So the hydrogen on the left needs a 2 in front of it. As soon as I do that, it fixes the hydrogen to an even number, but it makes my nitrogen multiplied by 2 as well. So I do my nitrogen times 2, and I have 2 nitrogens. Well, so far we're good. 2 and 2 nitrogens, 6 and 6 hydrogens. Let's carry on. I got 1 carbon, that's fine. 2 oxygen, 2 oxygen. Surely it couldn't have been that easy just by doubling it, but let's check. 1 carbon, 1 carbon. Seem to be good. 2 oxygens. 1 plus 1 is 2 oxygens, so those are good. 2 nitrogens. 2 times 1 is 2 nitrogens, those are good. 2 times 3 is 6 hydrogens. 2 times 2 is 4, plus 2 is 6 hydrogens. Looks like we are balanced. And we come to our last set. Another combustion, so let's see if we can't figure this one out too. We can use the same strategy as the last one. We can either make an equation, or we can ignore some oxygens. So let's break it down. I got 7 carbon, 6 hydrogen. I got oxygen with 2 and a 2. I got 1 carbon, got 2 hydrogens. I got oxygen with a 2 and a 1. First thing I notice is a 7. I don't like dealing with uneven numbers, so I'm immediately going to double that. So this left carbon gets a 2 in front. And if it gets a 2, the rest of these get a 2. Now this oxygen, only one of them get a 2. This 2 represents the oxygen gas. This 2 came from the carbon molecule. So multiply it by 2, get 4. So right now I have 6 on this side. Alright, now let's continue from there. So carbon's 14 and 1. 1 goes into 14 times. So my right carbon needs a 14 in front of it. As soon as I put a 14 there, it multiplies my oxygen as well. But only one of them. So this is 28. Let's do hydrogen next. So I got 12 hydrogen, I got 2. 2 goes into 12 6 times. So I multiply that 2 by 6 to get that 12 back. So my right hydrogen needs a 6 in front of it. Once we do that, it multiplies this oxygen by 6. So 28 and 6 makes 34. Alright, final step, our oxygen. I got 34 and 6. Problem is they're all split up all over the place. So I'm going to make an equation first this time. So I got 2 times 2 is 4 plus 2x equals 34. So I do 4 minus 4, get 30. 2x equals 30. Well, 30 divided by 2x is 15. So that means this is 15. So that's an equation way. The other strategy is you ignore the oxygen on part of it. And it's the same exact thing, really. Or one's just represented by a mathematical equation. So the way I do that, if I'm going to ignore oxygen, I need to ignore the oxygens on this carbon molecule. So 2 times 2 is 4. So I want to ignore these 4 oxygens. I'm going to pretend they're not there. That leaves me with 2 on this side. So that 6 goes away. Now if I ignore 4 oxygens on the left side, I got to ignore 4 on the right side. Now it really doesn't matter which oxygens I take. I just need to take 4, so I'm just going to do it from the total. So 34 minus 4 gives me 30. Well, 2 goes into 30 15 times. So 15 times 2 gives me 30, so I stick a 15 on the oxygen gas molecule, and that should balance it. Let's double check our work. 2 times 7, 14. 14 times 1 is 14. We're good. 2 times 6 is 12. 6 times 2 is 12. We're good. 2 times 2 is 4, plus 15 times 2 is 30, plus the 4 makes 34. 14 times 2 is 28, plus another 6, 34. We should be good. Alright, last problem. Separate it out. I got 2 sodium, carbon, oxygen, hydrogen, chlorine. There's a lot going on in this one. I got sodium, chlorine, hydrogen, oxygen. Now there's 2 of them. And carbon. Alright, there's a lot happening with this problem. Let's see if we can't figure it out though. First thing I notice, that uneven number. I don't like it. So I'm going to double this right off the bat. So I'm multiplying sodium by 2, carbon by 2, oxygen by 2. So 4 sodium, 2 carbon, 6 oxygen. Let's see if we can't go from there. Let's do sodium first. Sodium's 4 and 1. So 1 goes into 4 times. So this right sodium needs a 4 in front. That also multiplies my chlorine by 4. So if this chlorine is 4, and this one's 1, 1 goes into 4 times, multiply it by 4. So my left chlorine needs a 4 in front of it, which then multiplies my hydrogen. It multiplies it by 4 as well. Now this product hydrogen only has 2. Reactant has 4. 2 goes into 4, 2 times, multiply it by 2. So this hydrogen on the right side needs a 2 in front of it. That also multiplies this 1 oxygen. So now I got 4 oxygens total. So before we mess with this oxygen, let's check our carbon. I got 2 and 1. 1 goes into 2, 2 times. Our right carbon needs a 2 in front. Also multiplies the oxygen. Alright, so I got 2 and 4 making 6. Let's check. 2 times 2 is 4 sodium. 4 sodium. 2 carbon. 2 carbon. 2 times 3 is 6 oxygen. 2 plus another 4 oxygen makes 6. 4 hydrogen. 2 and 2 make 4 hydrogen. 4 chlorine. 4 chlorine. Looks like we are good. And that is balancing equations. Best way to get better at it is just practice it. So I recommend finding a whole bunch of problems, work them out. Try to find some hard ones. Find the ones that make you struggle, make you challenge yourself. And that's how you can get better. And again, you're still going to make mistakes, though. I still make mistakes too. If you do make mistakes while balancing equations, don't sweat it. It's going to happen. And if you ever get to a point where you're just stuck, try starting over completely. Start at a new point. Try a different strategy. And eventually you'll get it. That's all for this lesson. Hope this video helps, and good luck on your tests.